first compound which is given to us is toluene, right? And we are asked to do its bromination. So let's start. We make the molecule of toluene. We know what is toluene. If we write the methyl group, if we attach the methyl group with the benzene ring, right, then the molecule is known as toluene. This is toluene, right, students? And we are asked to do its bromination. So here we need bromine, and condition for bromination. What conditions are required, students? For the bromination, we must require Lewis acid catalyst, right? And here we use aluminium chloride as Lewis acid catalyst, aluminium chloride. Students, we know methyl group. This is the methyl group which is attached with the benzene ring. This methyl group is ortho para directing group, right? So it will direct the bromine atom at ortho and para positions. So as a result, we get the product like we make the benzene ring, right? And since methyl group is ortho para directing group at carbon here, so one molecule of bromine will attach at ortho positions, Br, right? And we get the next product here, the second molecule, methyl group is there, and the next bromine atom is attached at para positions. Here we have bromine. So here we get orthobromotoluene as well as parabromotoluene. For this purpose, we must require here 2 moles of toluene. I hope this reaction is clear to you, students. Now let's see what is the next reaction. Here nitrobenzene, we are asked to do the bromination for nitrobenzene. So first of all, we will write the structure of nitrobenzene. We know if we write a nitro group along with the benzene ring, this is benzene, students, and if we write a nitro group here, nitro group, we are asked to do its bromination, and we know what conditions are required for bromination. For bromination, we must require bromine as well as Lewis acid catalyst, aluminium chloride, or we can also use ferric bromide, right? So here we use bromine in the presence of ferric bromide. We can use ferric bromide, right? So we know very well. We will see what product is formed. Before writing the product, students, here you will notice nitro group is attached with the benzene ring. As we know, nitro group is meta directing group, right? Since nitro group is meta directing group, so it will direct the incoming atom at meta position. So as a result of bromination of nitrobenzene, we get here nitro group is attached, and since it is meta directing group, so it will direct the bromine atom at meta position, right? So as a result of bromination of nitrobenzene, we get meta-bromo nitrobenzene. I hope this reaction is clear. Now let's see what is the next reaction. Next, bromobenzene is given to us. The molecule which is given to us is bromobenzene, and we are asked to do its bromination. So we will make bromobenzene here. This is bromobenzene, right, students? If we make bromine along with benzene, then this is bromobenzene, and we are asked to do its bromination. Further, we will do its bromination. So conditions for bromination: we require bromine in the presence of Lewis acid catalyst. We can use ferric bromide. Ferric bromide will be used as Lewis acid catalyst, right? Now, since we know bromine, it is ortho para directing group. Since with benzene ring, bromine atom is attached, and we know very well this bromine atom is ortho para directing group, right? So as a result, the next bromine atom, it would come at ortho as well as at para position in the benzene ring. So one bromine atom here we get at dibromobenzene, 1,2-dibromobenzene, plus the next molecule which is formed, bromine, and at the para position we get bromine. So it is 1,4-dibromobenzene. We get the mixture of 1,2-dibromobenzene as well as 1,4-dibromobenzene. So here we need 2 moles of bromobenzene. I hope this reaction is clear, students. Now let's see what is the next reaction. Next, here benzaldehyde is given to us and we are asked to do its bromination. So we'll do the bromination of benzaldehyde and we will see what product is formed. First of all, we will make here benzaldehyde. We know what is benzaldehyde. If along with the benzene ring, we will make aldehyde group. Aldehyde group is attached with the benzene ring, right? This group is attached with the benzene ring, aldehyde group. It is known as benzaldehyde. We will do its bromination. We are asked to do its bromination, right? We do the bromination in the presence of ferric bromide, which is Lewis acid catalyst. Now, we know what is the nature of aldehyde group. Aldehyde group which is attached with the benzene ring. This aldehyde group, aldehyde group is meta-directing group. Aldehyde group which is attached with the benzene ring, this group is meta-directing group. Since this group is meta-directing group, so it will direct the bromine atom at meta position. So in the product we get bromine atom at meta position. So let's see what product is formed. Here we'll make the product. Make the aldehyde group with the benzene ring and bromine atom would come at meta position, right? This is a major product, right, students? So, and other product will be HBr. So this is the major product. We are asked to predict the major product. So we get the bromine atom at meta position. Now let's see, students, what next molecule is given to us. Next, benzoic acid is given to us, right? And we are asked to do its bromination. Let's see how can we do the bromination and what products are formed after the bromination of benzoic acid. So first of all, we make benzoic acid here. We know benzoic acid is, if with the benzene ring carboxylic group is attached with the benzene ring, then it is known as benzoic acid. We are asked to do its bromination in the presence of Lewis acid catalyst, that is ferric bromide. Ferric bromide, right, students? Now, if we do the bromination of benzoic acid, let's see what is the nature of this carboxylic group which is attached with the benzene ring. We know carboxylic group, this is meta-directing group, right? So if we do the bromination of benzoic acid, since carboxylic group is meta-directing group, so it will direct bromine atom at meta position. So we get the product with the bromine atom at meta position. Let's see what product is formed here. Students, we will make benzoic acid, right? In the product we will make here benzoic acid, and at the meta position here we get bromine, meta bromo benzoic acid. I hope this is clear, students. Now let's see what is next molecule which is given to us. Next is phenol. We are asked to do bromination of phenol, right? So how we will do the bromination? We will make the molecule of phenol. We know when we write hydroxyl group with benzene ring, then this is known as phenol. We will do the bromination of phenol in the presence of Lewis acid catalyst, that is ferric bromide, right? Okay, students. Now, first of all, we see the nature of the group which is attached with the benzene ring, hydroxyl group. Hydroxyl group is attached with the benzene ring. Students, we know hydroxyl group is ortho-para-directing group, right? So if hydroxyl group is attached with the benzene ring and if we are asked to do the bromination, then in the product we get bromine atom at ortho as well as at para position, right? So write the product. After the reaction we get the product like, here we get product with the benzene ring. Here we attach hydroxyl group and bromine atom would come at ortho position, right? Similarly, here we make the second molecule in which bromine atom would come at para position, OH, and here we have bromine atom, right? So we have ortho bromine. Now let's see, students, what is the next question which is given to us. In this question, we are asked to predict the major product of the following reactions, right? Now, here we'll see a benzene molecule is given to us, and these conditions, hydrogen in the presence of nickel at 300 degrees centigrade. These are the conditions for hydrogenation, right? It means under these conditions, we are asked to write the reaction of benzene. So, if we do the hydrogenation of benzene, we will get the product like, we can write the product this way. This is benzene is hydrogenated, right? Here we need 3 moles of hydrogen. So the product will be cyclohexene. Cyclohexane is formed, right? I hope this reaction is clear. Now let's see the next reaction which is given to us. In the next reaction, we are asked sulfonic acid, right students? Now if we do the nitration of benzene sulfonic acid, then let's see what is the nature of sulfonic group. Since sulfonic group is meta-directing group, okay? Sulfonic group is meta-directing group, it is attached with the benzene ring. If we do the nitration of benzene sulfonic acid, then it will direct the nitro group at meta position, right? So let's see which product is formed here. We write the product, we write the benzene sulfonic acid here, SO3H, benzene sulfonic acid, and nitro group would come at meta position, right? So as a result here we get meta nitro benzene sulfonic acid or 3 nitro benzene sulfonic acid, right? Now let's see what next reaction product is we are asked to do. Next reaction, in this reaction xylene is given to us, right? When 2 methyl groups they are attached with the benzene ring, then it is known as xylene. The common name of this molecule is xylene, or you can write as 1,4-dimethyl benzene. Now see what reaction conditions are given to us. These are the reaction conditions, that is alkaline KMnO4 and warm. It means these are the oxidizing conditions. Alkaline KMnO4, warm, these are the oxidizing conditions, right? Since there are 2 methyl groups which are attached with the benzene ring, so that's why we need 6 moles of nascent oxygen. So we write here the 6 moles of nascent oxygen, 6 moles of nascent oxygen. Now both the alkyl benzene ring remain intact, no reaction inside the benzene ring, right? Both the alkyl groups, they will oxidize to carboxylic group. Both the alkyl groups oxidize to carboxylic group, right students? So I hope this reaction is clear. Now let's see what is the next reaction. Now here we have 1,3-dinitrobenzene, right students? Which reacting molecule is given to us? It is 1,3-dinitrobenzene or meta-dinitrobenzene. Since both the nitro groups they are present at 1 and 3 positions, so meta-dinitrobenzene. The reaction conditions which are given to us, equimolar mixture of nitric and sulfuric acid at 120 degrees centigrade. These are the conditions for nitration. It means we are asked to do the nitration of dinitrobenzene. Now students, we know very well nitro group, it is meta-directing group, right? So it will direct the incoming substituent at meta position. This is the meta position. Now let's see what product is formed in this reaction. One nitro group here, another nitro group here, and the third nitro group would come at this position. Nitro group here. So it is 1,3,5 trinitrobenzene. The product which is formed is 1,3,5 trinitrobenzene. I hope this reaction is clear. Now students, will see what is the next reaction. Now here benzene is given, right? And this is the benzene molecule, students, right? This is the benzene molecule, and here we have alkyl halide, that is secondary propyl chloride. Secondary propyl chloride, alkyl halide, right? And here Lewis acid catalyst, aluminium chloride. Warm, it means the conditions which are given, these are the alkylation. It means we are asked to do the alkylation of benzene, right, students? So let's see what product is formed if we do the alkylation of benzene. Now here alkyl group and hydrogen atom, they will leave from here in the form of hydrogen chloride, right? So as a result, the product which is formed is, let's see the product. We get the product here. The position from where hydrogen atom will leave, right? This carbon is attached over here. Like this, we get the product. So in this way we get isopropyl benzene. The name of the product is isopropyl benzene. Isopropyl benzene. Right, students? I hope this reaction is clear. Now let's see what is the next reaction which is given to us. Now in the next reaction, toluene is given to us and we are asked to do the bromination of toluene. Students, we know methyl group which is attached with the benzene ring. Here along with the benzene ring, methyl group is attached, right? We know very well alkyl groups are ortho-para directing group. So if we want to do the bromination of toluene, then bromine atom would come at ortho as well as para positions, right? Now let's see what product is formed. We write the product for this reaction. Here we get toluene and one methyl group, one bromine atom would come at ortho position, while if you make the second molecule of toluene, here one bromine atom would come at para position. So in this way we get, I'm sorry students, bromine atom should be here. Here should we have bromine atom, bromine. So we have orthobromotoluene as well as parabromotoluene. 2 moles are formed. So here we need 2 moles of toluene. I hope these reactions are clear to you, students.